Hello everyone, today let's solve the problem number 572, subtree of another tree. So right, what the question states here, we are given two binary trees, root and subroot. You can clearly see here we are given two binary trees, one is root and another one is subroot. This one I'm speaking of root and subroot, right? So just give me a second here, 1 second. Yeah, we are given a we are given two binary trees, one is root and another one is subroot. You can clearly see here we must determine whether subroot is the subtree of the root. We have to determine whether subroot is a subtree of the root or not, right? So a subtree means a node in the root and all its descendant should exactly match the structure and the values of the subroot. So this is very important, just keep this in mind. So a subtree, again I'm telling, just listen to this carefully. A subtree means a node in the root and all its descendants. A node in the root, this one, a node in the root 4 4, and all its descendants means 1 2 1 2 here. So and all its descendants should exactly match the structure. So both the structures are same here, 4 1 2 4 1 2. This one has to match all its descendants, has to match the structure and values of the subroot. Values of the subroot here, this one, see, 1 and 2 we have, 1 and 2 we have, and it should, if this contains the this one, what do we call subchildren, like 3 something, any value here, right? 3 or something 2, and if this doesn't contain any subroot, this one subchildren, then also it fails. The value, the structure and the value of the subroot and the subchildren has to be same, equal, right? So just remember this one, right? So in this case it passes, right? So we have here a subroot is a part of the root. Subroot is a part of the root accordingly with the question. 4 1 2 we have, 4 1 2 we have, we don't have subchildren and we don't have subchildren here as well, and the value of the subroot also remains same, 1 2 1 2, and the value of the root also remains same. So we have to return this one, boolean value true in this case. Let's come to the second example. Let's come to the second example here. So we have root and subroot, we have 3 4 5 here. This one 4 1 2, we have 4 1 2, and for 2 we have extra this one, subroot, subchildren, subchild we can call it here in this case, right? So see here we have 4 1 2. So this is fine, we have the subroot 4 1 2, fine. This would, sorry, what happened here? So this is fine, just consider this one for the whole 4 1 2. So we would have returned true if we have only 4 1 2, but for the subroot 2, for the subroot 2, which is subroot of 4, basically 2 is a subroot of 4, right? For the subroot 2 we have one more child, subchild 0, but here in this case we do not have any subchild for the 0. We do not have any subchild for the 0 here. For this also it miserably fails here. In this case we have to return false. Don't get confused here, right? So this is clearly mentioned in the this one subroot definition, so don't get confused here. We have to return false in this case, right? So I hope the question part is completely clear, and they have given us wonderful examples just for the sake of understanding. Now let's do one thing. Let's discuss the approach followed by the edge cases, followed by the complexities, and then let's write the code. First, let's discuss the approach first, right? So we will be going with the DFS. We will be going with the DFS, or we will be going with a recursive DFS, right? So we'll be going with a recursive DFS, or the, you can just consider DFS or the recursive DFS. So just give me a second, 1 second here. So let's consider the same example here, man. Let's consider the same example. Root. So one, just give me a second here. 1 second. So here, yeah, let me consider this one. Root we have 3 4 5 1 2. Root we have 3 4 5 1 2, and subroot we have 4 1 2, and subroot we have 4 1 2. First, what we will do, first step, we will start the DFS on root. We will start the DFS on root. Root means first value we have 3, right? First node is 3 3, and this is not equal to 4. So subroot root is 4 and the root of the this one root is 3. So 3 will compare this with 4. 3 is not equal to 4. So it is not a match yet, right? Let's move on with the next step. We have to move to root dot left. As we are going with a recursive DFS, we will be going with a root dot left, nothing but in this case 4, and this matches the subroot dot value, first value 4. So 4 equal to 4. Yes, 4 is equal to 4 here in this case. 4 is equal to 4, right? So this is fine. This matches. Now we have to check the entire subtree. Now we have to check the entire subtree. Once we have found the root, now we have to check the entire subtree whether it matches with the subroot or not, right? So now we'll check if the entire subtree starting from this node 4 is identical to subroot. Both four nodes have children 1 and 2. See here, both the four subroots have the children 1 and 2 here in this case. 4 1 2, 4 1 2. The values crystal clearly matches here, right? The values matches here basically. Both four nodes have children 1 and 2, and they match in value and the position as well. The match in value and position or structure as well. In this case we have to return true. In this case we have to return true. Means it matches with structure. One matches with one here, and also this one 2 matches with 2 here in the second step. These three, this is fine. Finally, as it matches entirely, uh, we have to return true. We have to return true, right? So we have to return true. There is no subchildren for this as well here. This one, right? So in this case we have to return true. So this is the approach that we will be going with here. In this case, this is nothing but the recursive DFS. We will go with the recursive DFS. Just keep this in mind. So I'll just remove this one entirely. Now as we are completely familiar with the approach, let's quickly discuss the complexities part and then let's write the code. So what will be the time complexity here? So the time complexity would be big O of n into m. Big O of n into m. Why it is big O of n into m? Or we can just consider here m into n. Let's this will be correct basically. So big of m into n, because for each root, this one, for each root, what we will be doing here, we may compare subroot n for each root n, for each node in root n, sorry, for each node in root n, we may compare subroot m. We may compare subroot m. We may compare subroot m. So the overall time complexity would be big of m into n. And what would be the space complexity here? Space complexity would be big of h. The space complexity would be big of h, because we will be making use of the recursion as I have said. So call stack in the recursion or the recursion depth may go up to the big of n. Recursion depth may go up to the n. Overall it will be big of n, but it will be better to go with the h, as h represents the height of the tree. In the worst case we'll be considering the skewed tree, right? So in the worst case we'll be going with we have to consider the skewed tree, and h is nothing but the height of tree. So call stack in the recursion we have to consider along with the height. So it's better to go with the big of h rather than big of n here. So the space complexity would be big of h rather than big of n. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of m into n and big of h respectively, right? So now as we are completely familiar with the approach and the this one, what do we call, approach and the complexities, we are good to write the code. Let's start writing the code. Right, so here let's do one thing. Let's go with the base case. If the root is null, then we cannot have a subtree at all. If root itself is null, then we cannot have subtree at all. In that case we have to return false, right? So this is the base case basically. If root equals null, then we have to return false. The next step is, if the current node and the subroot are identical, then we have to return true. In that case. So we will be going with this one. For this comparison, let's go with the uh, we have to consider whether we have to compare whether it is same or not. For this, let's make use of the helper method. I'll just go with the private boolean here is same tree. This one will be tree node, and this one will be tree node t. This one will be t, not t. So within this one, what shall we do? If both are null, then they match. If both are null, then they match. So this is if s equals null and t equals null, then what we will do? We will return true. We will return true. This is fine. If one is null and other is not null, I mean, if other is having certain value, or if other isn't a null, then they don't match. In that case, we have to return false. Means I can write in this way. This if s equals null or t equals null, or I'm making use of, right, not and here. If either of s or t is null, so why I have given 3 here? 2. Either of s or either s or t is null, then we have to return false. Then we have to return false, right? So this is fine. The next step is if the values don't match, then also we have to return false. Means if the values don't match, then trees aren't the same. We know this one, right? They have mentioned in the question itself clearly. They have given the figure as well in the example, right? If the values don't match, then the trees aren't the same. Then also we have to return false. Means I can write in this way. We can articulate in the form of code in this way. If s dot val not equal to t dot val, then we have to return false as well. Then we have to return false as well. Now the final step is we have to recursively check for the left and right subtree. Means here you can just go with return is same tree, s dot left comma this one t dot left. This is fine. Also we have to recursively check for the right subtree as well. This is for the left. Let me copy the same thing here. Let me paste it over here. So this is fine. Instead of left, let me make this one right. So just give me a second here. What happened to this one? This one, let me make this one right. And also this one, let me make this yeah, right. This is fine. What we are doing here, we are recursively checking for the left and right subtree. We have done this one successfully. Next, let's make use of this one is same tree helper method within the main function. Within the main function or the main method. So here in this case, if the current node and the subroot are identical, then we have to return true, right? So here, if is same tree of this one, we can consider root and subroot. We can consider root and subroot. Means if the current node and the subroot are identical, then we have to return true in that case. We know this one, right? The question itself says the same. We have to return true. uh, Final step is else if it is not same, then we have to recur for the left and right subtrees. We have to recur for the left and right subtrees. In this case, we will go with the return is subtree. Sorry. So this one, let me copy this one and let me paste it over here. Is subtree of root dot left comma sub root. This is fine. We will go with or here. So let me copy this one entirely, make the necessary changes. So let me go with right here for this is fine. Root dot right comma subroot. Root dot right comma subroot is subtree of root dot right comma subroot. So this is fine. So let me format the code once and let me hit the run button. Let me hit the run button. I hope this works, man. This is it for the code. Have the compile error. Semicolon expected where number 5. Yeah, I had given semicolon, bro. Yeah, now you can clearly see the sample test cases are getting passed. So let me hit the submit button quickly. Let me hit the submit button quickly. Right. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct in this case. The code works absolutely correct in this case. Right. Yeah. I hope the solution part is completely clear along with the this one. What do we call? Approach and the complexities, right? I hope the solution part is completely clear along with the approach and complexities. For now, this is it. Thanks for watching, guys.